So 5.3 now, laws of logarithms. We're just going to take a look at some examples now. Okay, so let's take a look at some examples here. Alright, so taking a look at these examples, we're going to want to condense this problem together. Okay, and what I do when I condense is I normally do multiplication, then I'll do this part first because I see addition, I'll smush them together to make it smaller. And then I normally do subtraction at the end because that's addition. When I am expanding, I do that in reverse. I do division first, then I do multiplication after that. So to condense, I see these two and I see addition, and addition with logs means you multiply, so you smush them together to make a 10a. Then because there is subtraction sign, I know subtraction with logs means addition. So then I'm going to write this all as 1 with the 10a divided by 3. And there it is, condensed. First things first, when you want to condense, you need to get these exponents inside. So I'm going to move the 2 inside. I'm going to move that 3 inside. So that's 2, so that's a squared, but squared cubed, you multiply. If you remember back to the prereq section, that means you actually multiply to get a 6 there. Then this is subtraction, which is like saying division, so it's actually a squared over b to the 6th power. Alright, I know that it looks crazier, but don't make this more challenging than it needs to be. Alright, you gotta get rid of what's out in front, so I move that into an exponent, and I move that into an exponent. And then subtraction is like saying addition. Okay, so take them through. Alright, remember, you can't have a root in the bottom. You can't have a, which that'll eventually be, well, not eventually, you can't have a fraction on the bottom. So get rid of those fractions in the bottom. I'm going to take this entire thing, think of this whole thing as one variable, and since it's to the 2/3, what'll make a whole, remember back to the prereq section, you got to figure out what makes a whole, 1/3. So I take it to the 1/3 on both the top and the bottom. So that gives me 1 whole p to the 4th q to the 3rd, and this is what my top looks like. But then we have another problem. After I take that through, I have 3 halves, 4 halves, 4/3, 3/3. Alright, so I start simplifying. That's 2, that's 1, and I have 3 halves and 4/3, and we go. Remember, 3 halves I can write it as a half, and 2 over 2. So it's 1 and 1/2. That's 1 and 1/3, right? So really what I'm looking at is a half, that's a 1 whole, that's squared. That's a third, that's 1 whole, and that's a q. So now I start smushing everything that I can together. I have a p and a p, that's p squared. I have a q squared and a q, that's q third, and there they are. So now whatever I can simplify on the top and the bottom, I got to start doing. Well, I have p squared on top and p to the 4th on the bottom. The larger one's on the bottom, so that means I'll have a p squared on the bottom. And as you notice, the q's cancel out. Still not done because this will give me 2 roots, so I need to find a common denominator to smush them together. This is a big review from the prereq section. This is a really good problem. So I realize that a common denominator would be 6 for these, so I rewrite a half as 3 over 6, and I rewrite a third as 2 over 6. So now I can push them together, and that gives me p to the 5/6, and I can push them together. So next up is they all have the same base. Great. Remember when we are condensing these problems, since it's addition, I'm going to smash those together first. So I get 2m minus 3 times 2m. And then that 3, because it's minus that, it's like saying division. But I'm just going to multiply those together first to get 4m squared minus 6m. And then since it's minus, that's me combining my terms there with a division sign. And there's that one. With this one, got to move that half up top there, so boom. And then division means that we're going to end up having a fraction right there. But remember, not a problem. This is on the bottom, except you can't have a root on the bottom. So I'm going to multiply both the top and the bottom by the square root of y plus 3. So 2 square roots makes 1 whole, and that's what you have left on top. Now, because that's a root and that's not, we can't really smush them together, so we just have what we have. Now we're expanding. So with expanding, you want to do division first. So with expanding, I'm going to realize that that's subtraction. So I get log base 2 to the 2 root 3 minus log base 2, 5. That's done. But this, there's two numbers. So that's a number and that's a number. So I can separate those because it's multiplication with addition. That I can simplify to a 1 because it's log base 2, 2. So that'll simplify to 1. And this, I realize, hey, that's a root. That I can actually rewrite as an exponent. And then I can actually move that exponent out to the front to get 1/2 log 2, 3. And remember that I can simplify to a 1. If you have any more questions or concerns, once again, I know I go through the examples really quick because the answers just pop on the screen. But once again, slow it down and see the reasons why. All right, try the problems out yourself first. And I know that it's quick, but they're meant to be quick. Okay, these lessons are meant to go quick for you because you're supposed to pay attention in class, whether it's with me and you're my student or whether it's with another teacher. This is to refresh. This is to get things going back in your brain again. All right, and that's why I gave you a bunch of examples in the notes and a bunch more examples here. You got about at least a good 12 to 15 examples to look at to figure out what to do and what's going on. So when you look at your teacher's worksheets, you can use what you know to find your answers. If you have any other questions or concerns, let me know.